Insertion sort, selection sort, bubble sort, merge sort, quick sort, heap sort, binary search, breadth first search, depth first search. Do you know what an algorithm is? It's a big word, we use it a lot, but it's a lot simpler than you think. It's used a lot with social media platforms. Oh, the Instagram algorithm, or the Facebook algorithm, or the YouTube algorithm, and the word is used so often, but a lot of people don't actually know what it means. It's a lot simpler than you think. An algorithm is a step-by-step process that we use to deal with data, or we want some outcome. When dealing with big data, we have to use the right algorithms and we have to optimize our code so that we get our solution in the fastest amount of time. When you're dealing with 100 users on your Instagram clone app, you could do a double for loop and nothing's gonna happen. But if Instagram actually had double for loops, that could be a big issue. So you want to make sure everything's optimized to have the least amount of calculations, the least amount of steps that your computer has to do to get to that solution or outcome or whatever you want to call it. This video is going to be the first in a playlist that I'm going to be making, where I'm going to take each algorithm, break it down into theory, break it down into code, and we're going to go through it together. Before we start algorithms, we will be going over the little things like recursion and time complexity and whatever we need to jump into algorithms to really understand what they mean. If there's something you want me to do in this playlist, like you want to know what merge sort is or binary search or whatever, put it down there. I'm gonna make a list and I'm gonna knock them out. Algorithms don't always need to be complex. A lot of people, when they start programming, they do the fizz buzz question, like, there's a billion versions of it, but like the one I remember off the top of my head was, if a number is odd, turn it into the word fizz. Number is even, turn it into the word buzz. That's an algorithm. There's steps, and the computer follows the steps and gives you your outcome, which is this huge list of numbers and now a word. Whereas the algorithm for, let's say, Google Maps is going to be a lot more complex. You're going to need machine learning and so many things, and if there's a car crash on this road, find a way to redirect them and make sure it's the fastest way, and there's a lot more going on there. While knowing each algorithm by heart is not the most important thing, knowing when to use what and how to break down big problems properly is crucial to knowing how to do this stuff. That applies to most programming, but I'm going to repeat it in this situation because you could spend a lot of time writing code for something and then miss a step in your head and everything goes to shit. A good way to work on your algorithmic thinking is using one of the many sites we have out there, like Code Wars, Code Signal, Elite Code. There's so many of them, but just find one of those and do a bunch of questions on there, a couple every day. That's what I did, and it helped me a lot. There's a lot of algorithms out there, and you guys who are watching here who haven't done anything, it's going to be a lot of information to remember, so these videos will help you a lot because I'm going to try and make them short and concise. Learn the theory, learn the code, and that's it. There's so many algorithms out there. There's always a different one. There's always a newer, a better for this situation, that situation. It's almost like web dev frameworks. Let me show you what I mean. These are just 9 of the first ones I learned. Insertion sort, selection sort, bubble sort, merge sort, quick sort, heap sort, binary search, breadth first search, depth first search. Those are just introductory algorithms into this big pile of, hundreds of different ones you can use. When I started, the first 2 I learned was breadth first search and depth first search, and I wanted to go quickly over those. I'm going to do dedicated videos, but just to get you guys to see the kind of things we'll work with. So breadth first search and depth first search, just like the name says, they're searching algorithms. You have a tree, and in your tree you want to find something, so you got different ways of going about it. Let's imagine a family tree and we want to find John. With breadth first search, what's going to happen is we're going to start at the top and we're going to go across the width, so either left to right or right to left on each level of the tree, and once we're done a level, we drop down and we do the next one. This is good when you have a longer tree and you could just go through the levels quickly, but it's really bad if you have this gigantic wide tree and one level is like 1,000 people. That can take you forever. It's not optimized, so you would use something like depth first search, where it's the exact opposite. Instead of going across, and it goes up and down. So it would go, let's say, top to the most left, to the most left, to the most left, and then it would go up and start at the next one and just keep going down and down and down. As you can see, some of these have huge faults and some of these have huge gains. It depends on the situation which one you want to use. If you're super eager to learn algorithms like right now, first thing I'd recommend is look into time complexity and look into recursion. If you go into those and you find it's a lot of information and it's complicated, don't worry. Tomorrow I'll be posting a video on either recursion or time complexity, and then the next day I'll do whatever I did. If you're having a hard time understanding why we need to learn these algorithms and why we use them, think about it like this. If we can cut down from 10 steps to 5, let's say, for what it takes to log into your account, that's a big difference, because you're gonna have 100,000 people doing it constantly. They're not always important depending on what you're doing. Sometimes it's more important to just get focused on finishing the product. You know, if you're doing like a landing page or something and you have like a subscribe to our email list, you don't need to like perfect the code on that, right? It's just something that needs to run and it works and you're good. But if you're making an application that deals with payments or deals with like streaming or something heavy, you don't want it to be slow. When things are slow, people find it inconvenient and then they don't want to use it. So it's almost like a marketing tactic to make sure everything's fast. You know, when you go on Google and you search funny dog videos, they pop up within seconds. Imagine if it took 10 minutes. If you guys are curious on any like crazy algorithms, I would look into like Google DeepMind, Mar.io. It's this program where they taught the computer taught itself how to play Mario. So it learned the curiosity of seeing what's beyond the screen. I know there wasn't much in this video, but I'm bringing it to you guys. I'm gonna do this playlist. I'm gonna be consistent with it. And the days where I don't have a video ready for an algorithm, I'm gonna throw something else in, like a video editing video, or you know, maybe a short film or something like that. If you guys enjoy or just want to help me out, I'm trying to get to 1,000 subscribers so I can monetize my channel, and you can like the video, which helps me get back into the YouTube algorithm. Thanks a lot for watching, everyone. I really appreciate every single one of you who supports me throughout these videos. I'll see you guys in the next one.